Hi, my name is Caleb.
Hi, my name is Howard.
Hi, my name is Arjun, and our project was to send short videos over the radio.
Let's start by talking about compression.
In order to reduce the image to a size that can be transmitted in a reasonable time, we use the JPEG 2000 image compression scheme. We begin by decimating the image by a small factor to decrease the size and then use frame differencing to take advantage of redundancy in the time domain. We then transform RGB into its luma and chroma values, as human perception is limited in the chroma domain. We then implement the wavelet transform using biorthogonal filters on the iframes and Haar filters on the p-frames. This is to take advantage of the limited number of coefficients after Haar filtering. We then perform scaled quantization by assigning higher weights to the higher detail levels of the wavelet coefficients. Finally, we apply run length encoding and zip compression to losslessly reduce the size of the data.
Once the image has been encoded, the raw data is broken up into equal-sized chunks of maximum size 300 bytes. These chunks are then bit-stuffed so that a 0 is inserted to break up runs of consecutive ones. These bit-stuffed data are then inserted into packets. Each packet begins and ends with a series of 10 flags that can help to identify it. The packet also has a checksum to verify the integrity of the transmission. After the data has been packetized, the modem applies an AFSK modulation scheme to the packets. A sequence of zeros is appended before the first packet to help recover timing. The packets are converted to NRZI bits, which are encoded by mark and space frequencies of 1.6 and 3.2 kHz. These bits are then transmitted over the radios at a baud rate of 2000. The complementary radio receives the data and samples it at 48 kHz. A phase-locked loop is used to recover the timing of the transmitted signal. Packets are identified by finding the flags and are checked for accuracy. Once the initial data has been demodulated, inverse transforms are applied to recover the transmitted image.
Now let's see how it actually works in practice. Here we have two laptops, one connected to the receiving module and the other to the transmitting module. Over here is the transmitting module with a Raspberry Pi connected to an interface connected to a radio. This radio will transmit the image over to the receiving module, which we can see over here, which has the same setup. So now that we understand how the setup is worked, let's actually run the code. So first, Howard is going to run code to set up the receiving module, and now he's going to transmit the image that we've already encoded. We see that the transmitting module's radio lights up, showing that it's transmitting, and the receiving module is gathering the signal. Finally, we can actually hear the signal coming out of the modem. Now let's see how the image looks.